Hi, my name is Parker Chalk. In this project, I worked on the microphone inputs, the audio processing, and the 3D printing of the enclosure.
Hello, my name is Hannah Larry. I work on the Music Box project. I work on user input, system integration, interface, display, and I also build the custom PCB for our project.
Hello, my name is Fatima, and here's our project. And I worked on the speaker amplifier and the process of playing back pre-programmed songs.
This is Melody Storm. This is a music box that our team made. Um, so some of the goals for this project were to make a box that can record songs, that can play back those recorded songs, and can also play back some pre-recorded songs. Another big goal we had was to make a super clean and easy to use user interface. That's why we have a big screen right here. That's why we have 4 buttons and a control knob for a really robust user interface. But we did face some challenges along the way. Some of those challenges included actually recording the songs. We originally tried to use FFTs to do this and put it in text files, but this ended up putting too much of a memory constraint on our microcontroller, so we ended up using WAV files instead, which ultimately was the right way to go, because we were able to store many more songs. Another challenge we had was the 3D printing of this case. We had to go through a couple different iterations before we got a box that really clicked into place. So our team is very happy with how this music box turned out. We really liked how clean it was, and we really liked our user interface, though there's always room for improvement. And for us, we thought about making this battery powered instead of a wall plug-in. We've thought about making a volume control as well to try to give the user just more control. And those are two of the biggest considerations we have for improvement.
We are going to talk about our customer requirements for this project. The first one was that our system must be able to control lights. For that, we use an RGB matrix display and we also use lighted keys.
Customer requirement too, the system should be able to play pre-programmed song. To do that, we downloaded a couple of fun songs and saved them as a WAV file into our microcontroller. And the customer is capable of playing these songs by selecting whichever the customer wants and playing it. And the song will be played through the speaker.
So for customer requirement number 3, this requirement was to implement audio recording, specifically from 100 hertz all the way to 5 kilohertz. We did this by having a sample rate of about 10,000 samples per second. We stored all of those samples into an array and then put all of those samples into a WAV file. We implemented this by having us continuously sample audio as quickly as possible, and then once the 20-second duration was over, we then processed the audio into a WAV file to make sure we had as many samples as we could get in the recording time. We also made sure to have each of our WAV files be exactly 20 seconds long, and we tested our implementation with a tone generator and a tuner to make sure our frequencies were within 4%. For customer requirement 4, our design had to be aesthetically pleasing with no visible tape, cardboard, or anything like that. And as you can see, our design is custom 3D printed and it doesn't have any visible tape, cardboard, or anything like that. So this was a pretty simple customer requirement to do.
For customer requirement number 5, the system must be easy to use. To do that, we created a instruction manual for the user to follow on how to use the music box. The document can be found under the project artifact on our website for the music box. We had multiple people read the instructions and use the music box, and none of them had any issues using it. So that satisfies requirement number 5.
For customer requirement number 6, the system should be able to display its current state. For that, we're using our RGB matrix display and we are showing the current mode, either play or record, and also when it's playing or recording. Now I will go to customer requirement number 7. For customer requirement number 7, the user should be able to control the system through a built-in physical interface. All system functionality can be controlled through at least 4 physical inputs. As you can see on our box, we have 4 push buttons and we also have a rotary encoder. The user can use this physical interface to control the system of the music box. Thank you. Hi, I will go over the technical details of our project Melody Storm. To control our project, we are using an RP2040 Raspberry Pi Pico. It controls the display, the keyboard, speaker, and microphone. We have our microphone preamplifier, our speaker amplifier, our knob. Here goes our microcontroller and our keyboard. This connection leads to our speaker. This is our music box. If I take off the screen, you can see that everything inside is on our PCB. We don't have any jumping wires or anything else besides the cable that goes to our speaker over here.
Okay, here's our music box Melody Storm. I will show you how you can use it. First, we turn the music box on by pressing on the knob over here for a couple of seconds. When it turns on, it will show you this HUD on screen, and it will also start flashing colors on the keyboard. This image over here indicates that it's on. We have a keyboard over here. It has 3 keys, one for getting into the play mode, one to get into the record mode, one goes up the list, and one goes down the list. So let's say that we want to go up the list. Let's say 1, 2, 3, 4, 5, 6. And now we want to play the song that is recorded at number 6. We make sure that we are in the play mode, and then we click on the knob. To stop the song, you can click one more time on the knob, and you can select whichever of the 7 songs we have on the music box. Now, let's say that we want to record. You need to make sure that you're recording on number 8, because each of the slots we have over here has a pre-programmed song, and when we record over one of the other numbers, it will delete the pre-programmed song and start the recorded song. So make sure to record on number 8, so that you make sure that you have all the other pre-programmed songs. So now, if we want to record, we go to number 8, we select the record mode, you press on the knob one more time, and it gives you this symbol indicating that it's recording. You need to speak closely to the microphone over here so that it can pick as much as it can from your sound. It will continue doing that for 20 seconds, and after that it will show you an animation indicating that it's now processing the sound, which is what it's doing now. So now it's processing the sound that it recorded. Okay, now it has the song. So if you want to play it, you can go to the play mode, click one more time on the knob, and it will play it back. To turn the music box off, you press the knob for a couple of seconds, and now it's off.
To conclude, during this project, we faced many challenges. However, we were able to satisfy all our customer requirements and engineering requirements. Thank you.